All right. So looking at battery calculations, the majority of your systems, your regular horn strobe, just pull station, smoke detectors, systems are going to require 24 hours of standby and 5 minutes of alarm. That's pretty straightforward. And we can kind of look at how you calculate that or how that will be calculated on the plans. I've got some examples up here of a calculator that we'll kind of refer to. So this one is probably more detailed than some of the ones you'll see. Some of the ones will just give you values, and you'll say, okay, you have your panel, and it'll list all the components. Or in the numbers, it will factor in all the components. So there's no requirement to list all the components that are there. It's whatever's easier for the designer, however they like to do it, as long as they're providing you the numbers. So here we have our standby, and all this information will come from data sheets that are included in your submittal package for the components of the system. The standby and the alarm values are all listed on there. And they're figuring the quantity of the devices and the standby, what they're actually they're pulling, and then the total of that. And then you have your alarm, and then again, based on the quantity, the total. Then here we have, and that's just for the panel or panels. Here we have peripherals. So if we have the smoke detectors, the pull stations, the relays and modules, and whatever we're using is going to be listed here. And you would also see notification listed. Because the type of system this is, it was listed up here, with your panels. But typically, you would see your horn strobe values listed here. And that would, your values, your amp draw is going to it's going to vary based on candela setting. Your candela of your horn strobe or your strobe is where you get the vast majority of your amp draw. On the devices, it's not from the horn. So if you see different values listed, that's probably, it's because you have a 15 candela versus a 110 candela. To kind of help you understand that. So then we add up all these devices and we get a total of standby current for the system, for everything that's on the system. And we get a total alarm current for everything on the system. So if we look up here in the formulas box up here, we can see that we're referencing the total times 24, and that's how we get our 24 hours. You're figuring your battery and amp hours, so all times, you have to have the same unit, so it's pretty straightforward, pretty easy for standby. Now the 1.2 is a compensation factor, which we're going to talk about a little bit later where that comes from, but just know that we're providing the compensation factor in this formula right there. So we get our 53.72. That's how we get that. For our alarm, we've added them up. Now because it's alarm, so this one had CO detection, so we did it for 10 minutes of alarm. But for your average, you'll do it 5 minutes of alarm. So you'll see, and if they provide the formulas, that's fine. If not, to kind of give you an idea on how to calculate yourself, you would take your amp hour value here, divide it by 12 because 5 minutes is 1/12 of an hour, times 1.2 is your compensation factor, and have the value. Then you're going to add your standby and alarm time, because the way it's written is that you must provide ample battery for 24 hours of standby, then 5 minutes of alarm. So in order to make sure that happens, we add them. And here we have 55.16, and as far as a battery requirement. And so based on your battery manufacturer, you'll have your kind of set increment amp hours. Common are 7, 12, 18, 35, 55, and then you'll jump. Most manufacturers will jump clear up to 100. You'll have some that will be in between, but that's why you see the battery requirement of 100 amp hours here being defined. So let's talk about how our times are going to vary based on the type of system that we actually have. So if we have an emergency communication system, yeah, did you not see my Excel? I'm sorry, I just now saw your comment. Was my Excel worksheet, was it not visible?
We did not see it, no.
Okay, go to meeting. Oh, sorry. Try share. And then files and handouts. And then it should be, is it in one of your folders? Okay, well, you can go back to desktop. Just go back, just hit desktop, and it'll share.
Desktop is already being shared.
Oh. Now see if I can see it.
Start. Oh, I think. Can you see it now?
Yeah, we've got it now. Thank you.
Okay, I had not originally minimized, so if I'd read, that would help. Okay, so.
You have it in
I just
Oh, I got you.
Yeah. Okay, so this will make a little more sense now, hopefully. So we have our panel listed here. We have all the components of our panel, and this is where I was describing that it's much up to the designer and their preference whether they list all the components or just a general value for the panel current draw, standby, and alarm. So here, this formula, it's pretty standard. You're just taking the quantity of the component that you have based on the amp draw and then getting a total. Alarms the same way. We're just referencing the quantity to get our value. And that's pretty self-explanatory. Down here is where we're talking about to kind of help you understand and not to check the designer, but just so, or to double check the designer or so you understand where the values come from. So for standby time, for this one we did 24 hours, and we figured that based on our total for all our components. So here we see we've listed our initiating. We did not list indicating because they were listed because the type of system was listed up here. But your notification appliances would typically be listed in a different fashion, or could typically be listed in a different fashion. And so you would see that, and that would all figure into your total standby, or to your total values. Obviously, your notification and standby will be minimal, if any, because your horn strobes aren't on. But alarm, that's where you'll get your significant values for those. So for standby, we just multiply, because we figured all this in hours, amp hours of our batteries. We can just multiply it by 24. And get our standby time. We multiply it times 1.2 for compensation factor, which I talked about we would address later. So we can talk about it now, I guess. Compensation factor comes from, in 2007 and previous editions, you had to actually read the table for acceptable methods and criteria for batteries and read into the fact that batteries were still acceptable at 80% of they would consider passing at 80% of a load test. So you could have batteries that were 20% degraded and still pass them. So you have a compensation factor of 20% to 20% degradation. That's how you account for that, is your compensation factor. And like I said, prior to 2007, that was, took some reference. In 2010, they clarified that, and it is very explicit. So there, you don't have to try to explain where that comes from or why it's there. But you should always see a minimum of 1.2. That can vary based on engineering specs. So you may see 1.25, 1.3, whatever the engineer feels or wants to provide the client or the building owner. But at a minimum, it'll be 1.2 compensation factor, so 120%. As far as alarm time goes, here because we were using CO, we did 10 minutes, but we can modify this for 12. We would divide it by 12 for 5 minutes because 5 minutes is 1/12 of an hour. So we're just taking that value, dividing it by 12, and then multiplying that by the 1.2 compensation factor. We add the two, standby and alarm time, because it is written, which I already explained, because it's written that you have to have 24 hours of standby and then 5 minutes of alarm. And I already talked on that, touched on the battery increments. But we'll go back to our outline and talk about the different requirements based on systems. So we have emergency communication, so emergency evac. We require 24 hours of standby and 15 minutes of alarm if we have that type of system. If we have CO detectors on the system, we require 24 hours of standby and 10 minutes of alarm. The alarm is from NFPA 720. That's where we get that. And then generator. Even if you do have a generator that meets the requirements in either Chapter 4 of 2007 or Chapter 10 for fundamentals in 2010 or 13, you still have to provide a minimum of 4 hours of battery time for standby on your generator. So those are some requirements to be aware of. Some things that, as your system changes, your requirements change. Next, we'll look at voltage drop calculations. Those should be included with your submittal package. That is letting you know that the system designer has accounted for the voltage drop that will occur. This is applicable to notification appliances. So you start off with your panel, typically 24 volts, and the code says that you have to start off by degrading that 24 volts to 20.8. So once we do that, then we can start our voltage drop. And there's 3 ways to calculate voltage drop. You're making sure that at the end of their circuit, however they cover the building, how they designed it, that at the end of that circuit, you're actually going to have enough voltage to run the appliance, the horn strobe or whatever the device may be. So the three methods we have are point-to-point, load centering, and end of line. And to kind of give you an idea, code leaves that up to the authority having jurisdiction, whatever they want to accept. All three, obviously, you know, are good methods. But to kind of let you know the difference or the advantages, your point-to-point is going to be the most accurate or the most, you know, what it's actually run like. You know, what the electrician is going to wire it or what the installer is going to wire it up as. So that's probably the most accurate method. Load centering kind of gives you a middle ground, and then end of line is by far the worst case because it's calculated by taking the entirety of the circuit, so footage-wise, and then adding the entire amp load of that circuit at distance at the furthest point. And the minimum on that you're looking for will be based on manufacturer. So again, you'll have to reference your data sheet that's included in your submittal package and say, you know, the horn strobes that we're using today will function, you know, with a minimum of 16 volts. So as long as your voltage drop calculations indicate that you have at least 16 volts at the end of that circuit, they've provided you a good design on their notification, and effective that will work. Like I said, any of these methods. So, you know, if they figure it end of line, if it always works on end of line, you know, no matter, or I shouldn't say no matter what, but that gives you a lot of play for what actually changes during installation that the designer may not be able to account for. Like I say, point to point is the most accurate for what you plan on, but as we all know, with construction, things change. So we have end of line, or the line loss will only be applicable. Those values will be provided to you, and the calculation will be provided to you when you have a voice evacuation system. So to kind of give you an idea, the UL parameters for design for voice evac, you can, and that'll give to you in a number of dB loss. That's the factor that will be given to you, and you're allowed up to 3 dB loss. I've done some fairly large systems and never approached 1 dB loss. So it, you know, as far as line loss goes, you're going to be, speakers are pretty efficient. But the additional requirement to look for in your plans when you do have a voice system is acoustically distinguishable spaces. So we kind of, when we were looking at our testing specs earlier, and we saw in 2010 and 2013 the addition of average ambient and your dB levels that were recorded. We also talked about intelligibility, and I said we touch on that later. Here's where we're actually going to touch on intelligibility, because with a voice system, not only do you have to meet audibility requirements, you also have to meet intelligibility. So it's possible to turn up the speaker, you know, as far as tap the wattage of it so high that it's no longer actually possible to understand what's being said through the speaker. So we can make noise without it being understood. So that's what we're measuring here with intelligibility, is making sure that the message is actually understood, not only heard but understood. And there's several ways that is done. NFPA 10 and NFPA 72 2010 and 2013 both address this, and in the annex they have some good information as far as how to test for it and methods for contractors and what you're expecting. But on the plan side of it, to be looking for acoustically distinguishable spaces, they're telling you that because of room finish, or just generally, like, let's say we have a gymnasium, we have hard surfaces, we have lots of people, and you know, we all know how PA systems sound. You know, how hard it is to get that tuned in just right so we can all understand it. We would define, let's say, like a locker room or a gym, perhaps as an acoustically distinguishable space. And in that table, we would say that, yes, we do intend to meet audibility, but we are not designing to meet intelligibility in those areas because it's just not reasonable. And like I say, that's a little bit more, you can find more detail in the annexes as far as that goes. If you have questions on it, we can talk on it, you know, we can discuss it further, but I don't know how many of you are seeing voice evacuation systems being installed in your jurisdictions and how relevant it is. So if we have a lot of questions on it, we can sure look at it further. Perhaps I'll wait till the maybe the end when we do general questions, and if we have a lot of questions on that, we can deal with it then. The last component to look for on plans as far as the technical aspect of it would be an operational matrix. So here's where the system designer is telling you how the system is going to function. So they're defining an input for an output. And I've got an example here of a sample matrix, and this is from a system that's got a little bit of, quite a bit of variety in there.
New criticism reported an article Republican candidate for president is renewing his attack on the media amid several news reports.
Well, that's not, that copy's not going to work. Okay, here is a PDF copy of it. So the designer is telling you that a manual pull station will initiate the following outputs. It will activate common alarm signals. It will activate audible alarm, and that's for the panel. So your light will light alarm, and your panel will beep alarm. You know, you'll have the piezo that is indicating a condition. As far as notification, we will activate audible notification. We will activate visible notification, and we will display or print a status change. And it will transmit because it's a panel that's monitored by a central station. So we will transmit that alarm signal to the central station. In this case, this was for an R1 occupancy, and we had system detectors throughout, so we were going to initiate not only the horn strobes throughout the corridors and common areas, but we were going to activate the smoke detector sounder bases and the visible alarms if we're meeting ADA 2010. So we'll have our hearing impaired notification rooms defined, and so we'll have special requirements for those. But we're going to activate that. We're going to activate any of the horn strobes we have in guest rooms. Again, that's for ADA compliance. And then we are going to release our magnetic hold opens. We're going to shut down all our air handling units, and we're going to activate damper control. So we can see all the alarm conditions, you know, and what they're going to do. The designer is telling you that we do have elevator recall functions, and where it's going to recall based on the floor of where the lobby's at, the detector's at, we see that we do have fire hat because we're distinguishing operation on our elevator car, that if our equipment room smoke detector goes off, we're going to flash fire hat in the car. So we've distinguished what our CO detectors are going to do. And again, that's governed, how they report is based on NFPA 720. So we're going to have, in this case, we're going to have a supervisory signal, which that can be kind of tricky. You actually should have a CO alarm. So it gets pretty interesting on a programming note for a system contractor or designer, because like I say, you're lighting a light that is separate from a supervisory that's actually a CO alarm. So if we look at our hierarchy of how things are supposed to report in 2010 and 2013 editions of 72, we notice that CO detectors are in between the fire alarm and our supervisory signals. We have tampers, what they're going to do, and then we have all our trouble conditions. So, if you have a question, instead of having to call the designer, what a operational matrix for you as an AHJ is doing is telling you before you get to the final or before you're on site for construction that a duct detector, they're planning on duct detectors being alarm functions. And if you have an issue with that, if you're a jurisdiction that likes to see them as supervisory, during plan review, you can say, hey, I need you guys to change this, or inquire why they prefer an alarm or whatever. So it kind of gives you a heads up of what to expect, and to make sure that they're planning on programming the system the way that you expect it to operate. And you'll have some that are pretty simple. You have some pull stations, some smoke detectors, maybe a few duct detectors, and then your troubles and the supervisories. So you may not have an elevator, and you're not going to have sounder bases, and so this can be simplified a great deal. But this is just an example that I had to show. If you have any questions. Gosh, okay. Sure. I apologize again. Are you seeing the matrix now?
I think we have it figured out now. Thank you.
Okay, I'm sorry.
He did.
I'm not sure. I guess I got it figured out. If I go here and I minimize it, they should see. Okay, so
Well, and you'll have this too with your and the attachments that I send you.
so that'll be included. But I would imagine it didn't make much sense what I was saying if you weren't seeing the matrix. So I'll give you a minute to look at it, and if you have any questions, let me know.
I think this is good.
And knowing life and what happens. Introducing real-time delivery. One more reason to take our intelligence factors you can modify.
everybody else able to see the matrix, or did it not show up at all? So you can, if you go to the file .pddocs or document, it'll let you go and focus in to this screen. But sometimes I think it's just easier to share on desktop.
Okay, if you have any questions on that, we'll go back to when I'm in this view. I can't actually see the webinar, the chat, or anything. So I don't know if you have any questions. So do you guys see the outline now?
Charles, do you see the outline?
Yes, we can see the outline now.
But you couldn't see the matrix before?
Not until we hit that desktop Henry DuPont tab.
Oh. So it has.
Okay. So I guess everybody got a chance to view the matrix. I apologize. We're still working some of the bugs out here, so. But these will be emailed to you. So. Next topic is CO detection, which we've touched on a couple different times. As you do see, it affects a lot of system components. So we saw it affect the lifespan of detectors when we were just single station. We saw it affect battery calculations, and we saw it made a difference in how your system actually operates and how it reports from a programming and operational matrix standpoint. So NFPA 720 is the guidance for CO detection. And to kind of give a little bit of a, this is certainly not a comprehensive overview of NFPA 720, and this is not the only place it's required, but for you, when you're looking at plans or you're going out to do inspections on new buildings that are meeting 2012 IBC, you should be seeing these, especially in R1, R2 occupancies, adjacent to fuel-fired appliances, and IBC will guide you through where they're required, as far as floor separation, those issues. We already talked about the lifespan of detectors a bit earlier, and we talked about the electrochemical gel being the most prevalent technology utilized in the detectors. We looked at the reference materials on that, and then we talked briefly about the notification requirements. So again, your standard fire alarm, or your fire alarm notification is temporal 3, which is just the pattern. So it's the on-off pattern in a 60-second interval. And so the way we distinguish between a fire and a CO alarm would be by notification and temporal 4 being required. Um, so we kind of touched on it earlier, but when you see you have a CO detector, you should, and it's a system detector, so it's in with a fire alarm. You should also see a sounder base, because how else do we achieve that notification and distinguish between a fire and CO event without a sounder base? And just kind of a design insight there. And then NFPA 720, we already talked about that. And when we looked at our operational matrix, we looked at the difference it made because it was a different programming point. We're not just a supervisory signal, and we're not actually a fire alarm. We're a CO alarm. And like I say, if we look in NFPA 720, let's see if I can do this right.
We're looking at least 100 of these photos, however many cell phones are involved here, presumably will be back to the software enormous. And you know, I was looking at the website of another Colorado prosecutor who's got a lot of stats posted for Warren parents. He says that mainly 39% of high school kids engage in sexting activities. So it's a staggeringly high figure, and I think
This is just putting it all off of all access. So, okay.
Can you see
I'm
this?
thinking everybody can see this if I've done it right.
Yes, we can see it. Thank you.
Okay, cool.
Great. Okay. And so this is just kind of give you an idea of what NFPA 720 is actually going to require. And like I said, where it will reference over to NFPA 72 is when you're dealing with additions to 2010 and 2013 of 72, because you will actually see your testing interval for carbon monoxide detectors as a 6-month interval as opposed to a year. So that's one thing to note. And to be aware of when you're looking at an annual report, well, are they coming in and testing your CO, or are you doing it yourself? Or how are you meeting that requirement? And this is so our secondary power, so we also talked about that. That's where we get our 10 minutes when we have CO that's on. This also on a fire alarm system. Using that we see many of the same requirements. So our continuous power, we have the same 10-second requirement for primary power failure to transfer to the secondary power source. We share a lot of the requirements in our general section. So again, we see the same requirement to enunciate, or to be indicated within 90 seconds. That's the same as fire alarm signals. Like for alarm signals. Monitor it for integrity. Let's see. Look at different chapters here. So notification appliances, this will let you know where we get our 404 requirement. Just something to be familiar with if a designer is not planning on meeting this, and then you say, hey, where's your notification in compliance with? So, area. This is the, you'll notice this is the same in PA 720 as it is in 72 for our newer editions. We see the low frequency requirement for sleeping room notification. We'll talk about that. That's our next topic. Where they should be placed, you know, that many of the same requirements are outlined. You know, if you look at this compared to 72, we have the same duration as far as duty cycle for strobes, appliance height, and we see a very similar table for a room coverage for strobes. This is also found in NFPA 72. You know, you see the same coverage requirements for notification. So you share a lot of the same requirements. I don't know if that looks familiar to anybody, but as far as that's exact NFPA 72. And it's actually telling you that that's what it's referencing. And again, that would be referencing, because this is a 2012 edition, so it would be referencing an FPA 72 of the 2010 edition for spacing. And we have the same corridor requirement. I mean, you know, it's just telling you that we have many of the same requirements. And then if we are meeting our hearing impaired sleeping rooms of 177, and that will intensity required, same as an FPA 72, and then give our table reference.
Ask about our affordable plan options, even our zero green plan. Even if you have a different plan, it makes sense to find out more.
All right. So, okay. All right. We'll just do low frequency requirements. We'll talk about that now, and then maybe we'll do our break after that and come back for questions if we have any. So low frequency requirements we see. So if we're using IBC for new buildings, IBC 2012, then we're referencing NFPA 72 2010 version or edition. And so we see the low frequency notification requirement in Chapter 18 for that's our notification section. And we see it required in sleeping rooms. So NFPA, and I've provided background information on this because I thought it was pretty interesting, the effectiveness of low frequency sounder devices in sleeping areas as compared to the standard 3,000 hertz. So when we say low frequency, we're talking about a 520 square hertz. There's a margin in there, but a 520 square hertz notification as opposed to a 3,000 as your standard fire alarm. And I believe I put it in background information. Again, this is from System Sensor. They got some really good documents out there. And NFPA did some research, and that kind of goes over it. But they tested several different methods of notifying sleeping occupants, and they're listed here. And it's really impressive that we see the results indicated that the 520 square hertz wave signal was 92% effective at notifying hearing impaired as opposed to opposed to the required 75 decibels for 30 seconds. So previous to 2010, we were just required 75 decibels at the pillow, and that would be at our 3,000 hertz. And so you see that at the standard 3,000 hertz, only 56% of the participants woke at our standard 75 requirement. And then it's also interesting to note for alternative means of notification, where we previously would implement bed shakers, or that it was superior to that even as far as notification. So, like I said, that was really interesting to me. And then we see, so right now, obviously, we're past January of 2014. So all of your new construction that is constructed to meet IBC 2012 should, in sleeping rooms, should be meeting this low frequency requirement. And this is nice because it provides a little bit of explanation and a little bit of clarity. And it does note, that the 2013 edition changed some language to clarify that this is for sleeping rooms and the intent. So we're not changing our entire notification system to say throughout the building we have to meet low frequency. We're saying that in sleeping rooms we have to meet low frequency. And then it goes on to address that what if we have a voice evac system that we have sleeping rooms in. So let's say we had a high-rise hotel. So we're gonna require a voice evac, and so how do we accomplish notification? How do we get that low frequency notification in a voice evac? So we use it as the pre-alert tone. A lot of times your attention getter, typically you'll see it set as the whoops. You'll do the 3 whoop for attention getter on a voice system. And so here it just clarifies how you address that. So in 13, so this is a really good article here, Systems Centers put out to let you know based on what you've adopted the requirements, because like I say, we saw the requirement introduced in 2010 in NFPA 72. And then it goes on to a little bit more in depth on the octaves and harmonics and how it all works and why the square tone is so effective. So here's a nice table that kind of at a glance helps you understand based on occupancy what you're looking for, or for a designer to be cognizant of. So, and then this is helping this. So this has, this will apply to the designer, the power supply considerations. One thing to be aware of is that low frequency devices, because we're saying we're only putting them in sleeping rooms for new construction. So how do we actually know that the device that's installed is a low frequency device? They must be identified as low frequency devices. So a lot of times what you'll see on the devices is a very small marking I'll kind of show you here. Again, this is a system sensor data sheet. Rewind here. So this is standard horn strobe. I'm sure you guys have all noticed on your inspections. So how would we distinguish a low frequency? If you look on our data sheet, low frequency is written right here. So there's no, it doesn't have to be large criteria, like we have to identify our notification on there, and a lettering size and with the color, the distinguishing. But we do have to identify the product. So that's kind of gives you an idea of how to look for it when you do go on inspections or you do construction acceptance, that it is actually installed. And that's kind of, I guess, all I had for today. But we got quite a few questions that were from some different jurisdictions that we can address or that you can ask and kind of explain how they pertain or what maybe a little more insight based on what additions you're adopting or what you're following. So we can do that after the break if anybody has any questions. Let's say we'll take a 10-minute break and then come back for questions and any recap you guys may have. So we'll see you then.
See you in just a few minutes.
All right. I guess we're back. If anybody's got any questions, maybe everybody can unmute and I think that'd be easier than typing questions if we have any. Like I said, we got a couple that we're wanting to know, I think kind of as a response. So if you do respond to a fire, when should you reset the fire alarm for the building? And how can you assist the owner occupant in resetting the system, and some questions like that. So I think that as far as recommending a policy, I'm not going to say as soon as you guys show up that you should automatically silence the alarm. Typically what we would recommend is obviously that it's investigated, and then with whatever, I don't have a fire service background, so with whatever you guys, do to respond to verify that, indeed it is a false alarm, whether that's your thermal gun or whatever you're doing.
And this was a question that came in prior to, is that right?
Correct. Yeah, we received this question prior when we asked for a little bit of feedback for kind of some ideas on topics. Those were a couple of the questions that we received. So, I don't think want to speak to that as far as recommending a policy for everything or for every time. After you investigate it and you can silence it, and most of them are pretty straightforward. Acknowledge and reset are some options. Usually, if a owner can't get their system reset, it's because they're failing to acknowledge it. That's what I can tell you from like a contractor standpoint. So if you're out there and you've silenced the alarm after you've investigated and you still won't reset, you don't know why, you're hitting reset but it won't happen, have you hit acknowledge? That would be my advice, and that's kind of the way I understood the question. So I'm not sure if you guys have any questions.
Was there anything that wasn't covered that you would like to see more detail on, or is there anything specific to your area that Susan could answer for you? Are you awake? If you don't have questions, again, feel free to contact me afterwards if you do think of something, or if your staff has questions. It may be that once I send you the link to the webinar, and if you're sharing it, that kind of thing, that you have some, please feel free to reach out and we'll get those answered for you. I guess if we don't have anything further, we'll go ahead and wrap up. I did want to mention that we're having if you didn't get the email to the plans review webinar coming up next month, I believe that is December the 10th from 9 to 10:30. Brian Love is going to cover the plans review process. So get that on your calendar, or send me an email and I'll get you that information. But I do want to thank Susan for taking the time and talking to you all today and sharing her knowledge. And again, please let us know if you have any questions or anything like that. I will send you the link to the webinar so you can see that and the attachments. She's got quite a few attachments there, so I'll send those to you as well. So if we don't have any further questions, I thank you for attending, and be safe and let us know if we can help you.
All right. Thank you very much from Pittsburgh. Appreciate it.
Thank you.
Thank you.